Okay, wonderful young people. We're going to take a look at example number 2 now. I'm going to go ahead and give a second to read through this and underline any pertinent information. Okay, it does give us a couple pieces of information here. First of all, the mean ATM withdrawal is $67, so that's the population mean, and the standard deviation is $35, so that's the population standard deviation. Now, the first part of this is asking, what do you think the variable ATM withdrawals, do you think it's normally distributed? If not, what shape do you expect it to have? So I'd like you to think about that here and then pause the video, and then when you're ready for an answer, we'll see if you're right or not. So if we take a look at this and we draw a histogram, where would you expect, if this for instance was the amount of the withdrawal, and this was our frequency, in other words, how many withdrawals of that amount are, where would you expect most of these withdrawal amounts to be? Sorry, that should be a dollar sign there. Well, you probably have several smaller amounts, and then eventually, as the amount gets larger and larger, you would expect less withdrawals for larger amounts. So, in essence, do we expect this to be normally distributed? I would say no. What shape do you expect these withdrawals to take from the population? Well, if you take a look at this, it seems like it tails off to the right. You have your large amount of withdrawals on the left and a few large ones on the right. So we would call that, again, we'd probably say this distribution is skewed to the right. Hope you were correct. Now, let's go ahead and take a look at part B then. Okay, same information stated before, but this time we're going to say if a single ATM withdrawal is randomly selected, what's the probability that it is greater than $100? Now, if we take a look at this, it's asking if a single ATM withdrawal is randomly selected. So in this case, N is going to be equal to 1. We're looking at a single ATM withdrawal from the population of ATM withdrawals. What's the probability that it is greater than $100? Well, if we take a look at the shape, right away we said in the previous example, or in part A, that the distribution is probably not normal. The population shape is probably not normal. It is more than likely skewed right. Okay, the center would be at our population mean of $67, and our spread would be, since it's, again, we're not talking about a sampling distribution, we're only looking at a sample size of 1, an individual withdrawal, that is going to be the population standard deviation of $35. Now, it's asked us, so what's the probability that we get an individual withdrawal that is greater than $100? Well, ladies and gents, we can't do this. Why? Because the original population is skewed, and if we were going to find this probability, our sample size would have to be greater than or equal to 30 in order to be able to do this. Well, our sample size is only 1. So in this case, unfortunately, you can't do this. You can't use a normal distribution because our original population shape wasn't normal and our sample size is not greater than or equal to 30. So in essence, what's the probability? I hate to say it, but we cannot find this probability. With a normal distribution.